Okay, this is still the Unit 3. This is going to be Part 2. It'll be the second half of the review, so pages 4 and 5. If I were you, I would definitely circle number 7 because there are 2 of them like it, I believe, on the test. So that's a good place to start. And remember, in this one it says find the value of c satisfied by the mean value theorem for that function there over a given interval. Remember, the mean value theorem just basically says that the slope of a line through there is going to be equal to the derivative. At some point on there, they're going to be the same. So this is the one where you're going to need to take the derivative of this, and then you're also going to have to use that average rate of change formula from pre-calculus. So a couple things I'm going to do first. First, I'm going to rewrite my f of x, and instead of a square root, I'm going to write it as 2x to the 1/2 power. And then I'm going to remind myself of that average rate of change formula from pre-calculus that says f of b minus f of a over b minus a is going to give us the slope. Okay, so now that I have those written down, I can kind of go ahead and take my derivative here. So I take the derivative, and when I take the derivative, 1/2 times 2 is 1. So I'm going to get x to the negative 1/2 when you subtract an exponent, okay? And then that, just so we know, remember, a negative exponent means you're in the wrong spot of the fraction, so I would rewrite this as this over square root of x, okay? And now I'm going to use this average rate of change formula from pre-cal, keeping in mind that my interval over here is my a and my b. So really I need to plug in, so let's see, that'll be f of 9 minus f of 0 all over 9 minus 0. And let's see, so if I plug in 9 into the original there, 9 squared of that is 3 times 2, right? So 3 times 2 is 6. And then minus, if I plug in a 0, that'll just give me 0 divided by 9. So really, I'm asking myself to reduce 6/9. So when I reduce that, I get 2/3. Okay, so really the mean value theorem is saying that I want to take this derivative and set it equal to the average rate of change, because they're saying that somewhere on that graph, the average rate of change equals the derivative. Remember, the average rate of change is how we found slope in pre-calculus. So we're just setting those two things equal and solving for x. So I'm really just saying 1 over square root of x equals 2/3. To solve this, all you need to do is cross multiply. So you have 2 square root of x equals 3. Divide both sides by 2, and you get square root of x equals 3 over 2. And then you square both sides, so you end up with x equals this squared, right? Quantity squared. And remember, when you're squaring this, you have to square the numerator and the denominator. So my final answer is going to be 9/4. And that would be the value of c. And again, I would definitely make sure you know how to do something like that, because that one for sure shows up on the test. Okay. The optimization problems here, you could have over here solved for y instead of x. Either way, you should end up with the same answer there. Make sure you know how to do this one like 8 and 9. Those are definitely both on your test as well. Okay, so moving on to the calculator section. So it says the derivative is given by this here. For which values of x, if any, does f have a relative maximum? So here they're asking you to find the relationship between the derivative and the original. So if you have your calculator, okay, how you would type this in over here. So turn this on. Oh, I already got it in there. So y equals, okay, you're going to hit your y equals, and you're just going to type it in. So you just type in x squared, and then in this one it is minus, right, ln, and then it's 5x, close it. So when you hit graph, this is what you'll see. Oh, you won't probably see that. Let me change it, because the original window that you are going to see is going to look more like this. Okay, so remember, when you are given the graph of the derivative, you really care about where the derivative is positive and where the derivative is negative. My suggestion here would be to make a sign chart. And if you want to zoom in, just hit zoom, and then it's choice 2. You can kind of zoom in there, and you have to hit enter for the calculator to actually do it. Okay, so I'm just going to scooch this up. Okay, So here's what I'm looking at. Again, this is my suggestion, is to do a sign chart. You don't have to. But I think it kind of makes it easier to see. And you're like, well, if I'm worried about where my derivative, right, goes from positive to negative, that means I want to know this part here where it's positive, and then this part where it's negative, and then this part where it's positive. So really I'm concerned about those two things right there. Well, those are called the zeros. And to find those on your calculator, okay, you hit second, then the trace key, you find the zero. So you select 2. It asks you to go to the left of it. So you kind of go near the 0 and hit enter. Then you arrow a little to the other side of where it crosses the x-axis there and hit enter twice. So when you do that, it'll spit back that first critical value. So that's going to be at 0.209. And then it looks like there's another spot. So you hit second, trace, zeros again. So we're going to go arrow over till I'm just near it, and I hit enter. Then I arrow to the other side of it, and I hit enter twice. And then this time, it tells me I am at 1.393. Okay, so looking at the graph, I don't even need to plug in anything. I knew that it was positive to the left of that, it was negative in between, and it was positive after. Well, what does that tell me about the original? Remember, that's what the beauty of the sign chart is it gives you the relationship between the derivative and the original. So that means my original was increasing, then the original was decreasing, and then it was increasing again. Well, if something goes from increasing to decreasing, that means you have a maximum there. And then if it goes from decreasing to increasing, that means you got a relative minimum there. And then I need to make sure I answer the full question. Here it says, does it have a relative max? Yes, it has a relative max. So I would say relative max at x equals 0.209. And again, since you have your calculator, you could go back and plug this into the original to get the actual point there, but oh, no, you don't even have the original, so you wouldn't be able to do that because you're only given the graph of the derivative. But it does have a max there. Okay, so that is how you would tackle something like number 10.